Okay, so I had to stop the previous video, so I will continue here. I was talking about this example that how did I round it. Okay, so here I have here in the yellow part you can see I have I have subtraction, and before subtraction I have to do the multiplication. So based on BEDMAS, multiplication of 2.84 with 5.11 is first. So in that case, when you want to round and you think all the numbers are approximate, you have to round so appropriately. You have to first round based on the multiplication, which is to the least significant digit, and then you round based on the subtraction, which is to the least decimal place. You have to do based on that. Okay, so here I just want to show you with my calculator. When I do 2.84 multiple 5.11, okay, so I see 14.5124. Remember, I'm not changing this number, I'm not rounding here. No, I just round at the end. Last semester you learned you have to round at the end. That's it. You don't round in the middle at all. Okay, so if even you have to round, for example, for first part of the question, then for the second part, if you want to use the same number from the first part, you have to use more digits. And you saw that last semester in word problems for chemistry part. Okay, so that's that there. And then here I can show you, I first multiply that, and then I see, okay, based on significant digit and based on multiplication, I need 3 significant digits. So I need to think about 14.5 because that's 3 significant digit. And then I ask myself how many decimal place I have. Okay, I have 1 decimal place. That's why here you see this number 1 decimal place here. Okay, see, I multiply them, and then I say, okay, what's the operation? Multiplication. How do I round? To the least significant digit. Okay, to the least significant digit. So I want I need 3 significant digit. 3 significant digit, I have 3 significant, so I have to round to 3 significant digit. So when I do that, then I would say, okay, 3 significant digit I have. I look at my number based on 3 significant digit, how many decimal place I see. Oh, okay, 14.5, 1 decimal place. The other one is 2 decimal place. Okay, so I do, okay, so I round to 1 decimal place, but I don't round. I just use the same number, minus 3.82, and this is 10.69, which I round to 10.7. I round to 10.7, and then that's it. Okay, so now I continue here. I continue, so here, okay, so let me see. So here, yes, I talk about rounding of 10.69 to 10.7, so I can show you here. And then for the other one, it is just multiplication for the green one. So I just round to the least significant digit. 3 significant digit is the least one, so I round to this. Okay, and the first one, so I didn't need to round because it was just one number, 2.84. Okay, and multiple a squared, multiple a squared. Okay, so here now I want to talk about this number. I want to talk about this squared one. What do you do for this squared one? Okay, so this squared one is a plus b squared. Some students, they say it's a squared plus b squared. I want to say no. Okay, many of you know, and you would say, okay, I know it, you don't need to explain. The reason I say, because I want you to know that these mistakes are seen by me. And sometimes when a student are in rush or they are maybe stressed, they make those mistakes. Okay, so you have to say this, a plus b squared. You can learn this by Pascal, or if you don't remember Pascal, you can say, okay, this is a plus b multiple a plus b. Okay, so it is a squared plus ab plus ba plus b squared, which is a squared plus 2ab plus b squared. Done. Okay, see, this is the answer. So I don't forget that I have this guy as well, so this term as well. Okay, so now I have some exercises for you. So x equal 4 and you have substitute to find the answer. So you put x equal 4 or x equal 5 or y equal 3 in all of these when you see x, when you see y, and just based on bed math calculate the answer. So these are just exercise. Here it's simplification. How do you simplify here? Okay, so you multiply, you collect like terms and do just that. Okay, so these are just practice. Here, this is Pascal triangle here. Okay, so I told you that you need to, so you need to know here, okay, you need to know, yes, you need to know, for example, power 1, power 2, power 3, for some of the, just, for example, a plus b, for example, or x plus y. This is what I did right now in the other question. Okay, so in just in a few minutes ago, I did it. Now I want to show you Pascal triangle. Okay, so look at this. What do I do when I have a plus b power 0? Okay, I know if I have a number plus 0 is 1. Oh, okay, so I can write 1 here. Okay, so 1. How about if I have a plus b power 1 again? Okay, so that's 1, 1, because it's a plus b. Okay, a plus b power 1 is a plus b. So it's 1a plus 1b. Oh, okay, good. A plus b squared, I show you there. It is a squared plus 2ab plus b squared. Now I want to see how can I find these numbers. Okay, so I can say I have a triangle. This side of the triangle is just 1, 1, 1. This side of the triangle is just 1, 1, 1. But the middle one is made by addition of two others. Okay, so you add these two and just put it here. You add these two and just put it here. You add these two and you just put it here. You add these two, you just put it here, and put it here. Oh, okay, so now I know how can I make my triangle. I start from 1. One side is just 1, 1, 1, 1. The other side is just 1, 1, 1, 1. And in the middle, I have to add the two top one. Sorry about that. Okay, I just have to add the two top one. So 2 is 1 plus 1. 3 is 1 plus 2. 3 is 1 plus 2. 6 is 3 plus 3. And this. Okay, so how do I use these numbers? These numbers are coefficients. Where? When I want to write a plus b power and not just a number. Maybe power 0, maybe power 1, maybe power 2, maybe power 3, maybe power 4. Oh, okay, so how do I write that? Okay, for example, let me talk about power 4. So, first of all, when I have power 4, okay, I have power 4 here. I give you this question and I want you to find the answer. Yes, I want you to find this. Okay, I want you find these terms. Okay, yes. How do I start? When I have power 4, I need 5 rows. So I start from 1, 1, 1, 1 for the left side, 1, 1, 1, 1 for the right side. Okay, so like this, 1 and 1. And then in the middle, I can find these numbers with addition of 2 top. Okay, so 2 is 1 plus 1. 3 is 1 plus 2. Okay. How many rows I need? Okay, when I have power 4, I need 5 rows. These numbers give me the coefficient. Okay, how do I write that? How do I write, for example, the terms? The terms are just coefficient, multiple, variable to the power. How do I write variable to the power? I start from a power 4 and then I go to, I reduce from a, I add to b. I reduce from a, I add to b. I reduce from a, I add to b. Okay, so a power 4, then a power 3, b power 1, a power 2, b power 2. I reduce, add. How do I know I didn't make a mistake? When I look at here, I see this is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. And 4 is 4. Oh, okay. So when I have power 5, what should I do? Okay, when I have power 5, I can write it here. A plus b power 5. Oh, okay. So I need 6 rows. Yes. So I do 1 here. And here 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 5 plus 1, 5, and another one. Oh, okay, so I need red here, so I change the color. Okay. So how do I write, so the variables? Oh, the variables. I start from a power 5. I go to a power 4b, a power 3b squared, a power 2b cubed. Okay, a b power 4 and then b power 5. Okay, what do I put here? I put plus because I just see plus. Okay, so how about if I give you power 6? You need 7 rows. You need 7 rows. Power plus 1 rows. Okay, those numbers that you write through the triangle gives you the coefficient. Then you do a power 6, a power 5b, a power 4b squared. So you continue this the same way. Now maybe as a practice you can start, for example, as a practice you can do 2x minus 3y, for example, power 3. You can see what is the answer. Okay, see, okay, power 3. So oh, okay, I can think about this here. Oh, okay, so it is 2x power 3, yes, plus 3, 2x power 2 multiple minus 3y, plus 3, 2x power 1 multiple minus 3y power 2, plus minus 3y power 3. Okay, so but after I'm not done, I have to calculate. 2 power 3 is 8, so it's 8x cubed. Okay, then 2 power squared, so 2 power 2, which is 2s squared, so 2s squared is 4 multiple 9, right? So multiple 9, so I have to calculate. Okay, so 4 12, yes, so it is minus 36 x squared y. The other one is, okay, the other one is let me see, one of them plus, one of them minus. Okay, so the other one must be plus here, the other one must be plus here. So let me see what's going on here. Oops, what happened? Okay, so the other one is 3. Okay, so 3 multiple 2 is 6, 6 multiple 9 because minus 3 is squared, so 54, so it's 54xy squared. And the other one, okay, minus 27 y power 3, minus 27y cubed. Okay, so that's the answer here. So remember, if I don't have a, for example, instead of a I have 2x, I have to continue to calculate. If I don't have just b, I have minus 3y, for example, I have to continue to calculate. Okay, and then I have to find these numbers, right? Okay, so you can practice, for example, to do 2x minus 3y power 4. That can be your practice. Find the answer. So the next one is solving algebraic equation. How do you solve an algebraic equation? Okay, first of all, you have to look at the question to see if you have an equation. Because sometimes I see a student, they don't have equation and they try to solve it. Okay, so maybe you don't have equation, you just have algebraic expression. Okay, in that case, you don't solve it. Oh, perfect. If I have equation, I solve it. How do I solve? When I say solve for x, means I want to find the answer for x. Means I want to isolate x. Okay? So, oh, okay, so I want to see x equal a number, or maybe x equal some other variables. If I say I don't want to see x two side, no, I want to see just one x, one side. And the other side may be number, maybe other variables. That's it. Okay, so in that case, first I have to remember, I have to simplify each side if I can. If I can simplify each side. Then, when I am done by simplification, I can isolate. Means whatever has x, I keep it. Whatever doesn't have x, I just move it. If I move, I change the sign. Then again, I simplify. And then when I reach to this, I can say, oh, okay, I divide both sides with the number beside x. And then I find the answer. Of course, it's not easy to follow what I said. So I have to do a question. Oh, okay. So n plus 7 equal 10. I want to solve for n. Doesn't matter. I can solve for y. I can solve for x. Okay. When I say I want to solve for n, I want to isolate n. Oh, okay. Whatever has n, I keep it one side. Whatever doesn't have, I move it. Okay. So n minus 7. Why minus 7? Because I move it. When I move it, I change the sign. Oh, okay. N is equal 3. So how do I know I didn't make a mistake? I have to substitute. Left side is 3 plus 7, which is 10. Right side is 10. Oh, okay. 10 left side equal right side. Equal right side. Left side equal right side. Okay, so they make a mistake. Sometimes I see a student, they notice left side is, for example, is not equal right side, and they just continue to the next question. That's wrong. If you see left side is not equal right side, you have to check your work. Oh, okay. How about here? Okay, so here I said, okay, ax equal b. So I divide both sides with a, so it is ax equal a equal b divided by a. So x is b over a. Yes? Okay. So x is b over a. How about here? Here is n over 2 equal 4. Okay, when I say I want to solve for n, means I want to isolate n. So I want to see n alone. So what I see divided by 2, I multiply both sides with 2. Do I do anything wrong? No. When I multiply both sides with number, when I divide both sides with number, when I add something to both sides, when I minus something to both sides, when I subtract from both sides, I didn't do anything wrong because I didn't change my question. Okay, when I multiply both sides with 2, perfect, doesn't matter. My question didn't change. Okay, so it's 2n over 2 is 8. Oops. So n is 8. Oh, 8 is the answer. How do I know the answer is correct? I just substitute. Okay, now practice questions. Okay, so can I simplify left side? No. Can I say 15x minus 9 is 6x? No. 15x is apple and 9 is orange. I can't. Oh, okay, so this is 15x minus 7x. I move whatever has x one side. If I move, I change the sign. If I don't move, I don't change the sign. Eight x equal 4, and x is 4 divided by 8. I divide both sides with 8. So it is 8x over 8, which is 4 over 8. And then x is 1 over 2. Good? That's the answer. Perfect. So now I do the second question. The second question is not like the first one. The second question needs simplification. Oh, okay. BEDMAS. I have to follow BEDMAS. Oh, can I do anything for the bracket? X minus 2? No. Okay, so what can I do? I can multiply 3 inside. Okay, so it is 5 minus 3x plus 6 equal 12x minus 4. Good, good, good. Can I simplify now? Yes. 11 minus 3x equal 12x minus 4. Okay? Okay, so sorry about that. So it is minus 12x minus 3x equal minus 4 minus 11. Okay? When I move, I change the sign. Which one I move? X to one side, numbers to the other side. Whatever has x one side, whatever doesn't have x to the other side. Okay, good, good, good. So it is minus 15x equal minus 15. Okay, so x is minus 15 divided by minus 15, which is 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. Yeah. Okay, so how about this here? How about this question? Okay, yes, that's exactly the same, but I have to simplify. Okay, so 21 minus 6x plus 2 equal 12x minus 3. Okay, okay. Simplify each side. Okay, okay. 23 minus 6x, 12x minus 3. Oh, okay. Now I am in just the position of this question. The position of this question. Question number 1. Okay, which I have to move. Okay, so it is minus 12x minus 6x equal minus 3 minus 23. Yes? Okay, so which is minus 18x minus 26. Oh, so what's the answer? X is minus 26 over minus 18, which is 13 over 9. Yes? So it is 20, because minus and minus cancel, so it's 26 over 18, and which is 13 over 9, because I have to simplify. If I say simplify the answer, you have to simplify. Yes. Okay? So far so good. How about here? Oh, here. Okay. Look at this question. This question, yes, it has fraction. I know it has fraction, but it has one ratio one side and the other ratio the other side. Look at here. If you have a over b equals c over d, is not the same as a over b plus c over d equal e over f. These are not the same. Here you can do cross multiplication. Here you cannot do cross multiplication. No. Not here. Not here. You can't. So use this. Just use this chance, because when you have one ratio one side, the other ratio the other, another ratio the other side, you can do cross multiplication. Okay. Here you cannot do cross multiplication here, because you have plus. You have something plus something else. Okay. So you can't. Okay. So here 4 times 2x minus 4 equals 7 times 2 minus 2x. So it is 8x minus 16 equal 14x, sorry, equal 14 minus 14x. Oh, 8x plus 14x equal 14 plus 16. 22x equal 30. X is 30 divided by 22, 15 divided by 11 is the answer. Maybe I say I want to see the answer in mixed fraction, for example, which is 1/4 over 11. So if you have one fraction one side, another fraction the other side, use this chance to do cross multiplication. So means this multiple that, and this multiple that. In this case you can't. In this case you cannot. So my recommendation, which works for all of them, even the one that you did cross multiplication, is this: multiple both sides with least common denominator of all the denominators. Here is 6 and 1, which is 6. Oh, okay, so I have to multiply both sides with 6. So it is x over 6 plus x equal 21. Yes, I multiply with 6. Remember, for the first one you cancel 6 and 6, so don't write 6x. No, you just write x because you cancel 6 and 6. For the second one you write 6x equal, don't forget, some students they just write 21. No, 21 multiple 6. So it is 126. Oh, okay, so it is 7x equal 126, and x is 126 divided by 7, which is 18 is the answer. Oh, okay. So 18 divided by 6 is 3 plus 18 is 21. Left side and the right side is 21. Oh, perfect. I didn't make any mistake. And that's correct. So far so good. Okay, so I want to see how many question here. Yeah, these are just we go to yeah. So 1, 2, and 3. Yes, so I finished them. Yeah. So what do you do here? Okay, I multiply both sides with least common denominator of 4 and 6, which is 24. Oh, okay. 24 divided by 4, 6. So 6, okay, maybe I change the color just to have your attention. So 6 multiple 3x minus 160 plus 3, no, 24 divided by 6 is 4. Yeah. Okay, so 4 let me see. I just want to I think I am tired because yes, I made a mistake here. Least common denominator is 24. One of the common denominator is 24, but least common denominator is 12. Oh, I made a mistake. Yes, I think I'm tired. So least common denominator is 12 here, not 24. Okay, because how do I find least common denominator? You can do any method you want, but what I do is this. 4 is 2 squared. 12 is 2 squared multiple 3. Sorry, 6. 6 is 2 multiple 3. Okay, so I use any number with the largest exponent. Any number that I see with the largest exponent. Oh, okay. So the answer is 2 power 2 multiple 3, which is 12. Okay, perfect. 12. Yeah? Okay, so 12 is that. So here 12 divided by 4 is 3 and 12 divided by 6 is 2. Yes, I don't need to. If I use 24, numbers will be large and I have to simplify. I don't want to make that trouble for myself. No, I use least common denominator because I don't want to make the numbers large. When I make numbers large, the more work will happen. The more work, the more chance of mistake. And I don't want that. Okay, so it is 9x minus 348 plus 360 minus 10x equals 0. Oh, okay. So this and this, this and this. Okay, so minus x plus 12 is 0. Oops. And x is 12. 12 is the answer. If you use 12, then you can see left side must be 0. Okay, and equal must be equal right side. Okay, how about this one? How about this one here? How about this one? Okay, so do you flip them? Do you just flip them? No, you cannot, because you have two fraction one side, so you can't. Okay, so what should I do then? Okay, so what I do is this. Least common denominator again. Oh, how can I find least common denominator here? I have x plus 2. Doesn't matter. Here, see, I have x plus 2 and I have x and I have x multiple x plus 2. Okay, what is least common denominator? Okay, see, I use this and I use this. Okay, so least common denominator is x multiple x plus 2. Oh, so I multiple both sides with x plus 2. Okay, so what happened then? Or I can say I make all the denominators, for example, the same as each other. Okay, I can say that. Okay, so maybe you would ask what happened here. Okay, think about this as, for example, this. See, if I have 2 and 3 and 6. 6 is 2 multiple 3. Yes. So least common denominator is just 2 multiple 3, which is 6. Okay. Think about this way here, as x plus 2 is 2 and x is 3, and then I have x multiple x plus 2. Okay. What is this common denominator? Just 6. Yes. Okay. So now I can say this. Okay. I have 3 over x plus 2. Okay, I multiply top and bottom with x. Why? Because I want to make denominators the same. Oh, okay. Equal 5 multiple x plus 2. Okay, good job. Divided by x multiple x plus 2. Yes. Plus 4 x multiple that. Oh, okay. So here I'm fine. Oh, okay. So now I have 3x over x multiple x plus 2 equal 5x plus 10 plus 4 over x multiple x plus 2. Yes. Yeah. Okay. So now I have one ratio one side, the other ratio the other side. Okay, one fraction one side, the other side, and I see these two are equal. Okay, so I am doing the same thing if I had a number. Okay, so I use least common denominator. I show how did I use least common denominator with 2, 3, and 6, and then I multiply top and bottom with just one term, just to make the denominators the same. Denominators the same. See, denominators are the same. Okay, so when I have denominators the same, I can add them. 5x plus 10 plus 4. Okay, so now 5x plus 10 plus 4 is the same as 3x. So 5x plus 14 is the same as 3x. So 2x is the same as minus 14. And x is minus 7. X is minus 7. You can use minus 7 to see if left side equal right side. The last but not least question I will do here, and then I just finish this video, which is video number 5. Okay, so here yes, so here. Okay, so how about here? So do you do least common denominator, or you would say no, I have another easy way? Oh yes, I have one ratio one side, the other ratio the other side. So I do just cross multiplication. So 3x plus 5 multiple 2x minus 1 equal 3x minus 3 multiple 2x minus 3. Okay, so that's 6x squared minus 3x plus 10x minus 5 equal 6x squared minus 9x minus 6x plus 9. Yes, so this one and this one cancel each other. This one and this one is 7x minus 5, and I have minus 15x plus 9. Okay, so I have 22x equal 22x equal, okay, so maybe I show you a step by step. Okay, 7x plus 15x equal 9 plus 5. Yes, which is 22x equal 14. And x is 14 divided by 22, which is 7 over 11. That's the answer. So if you want to make sure the answer is just correct, you have to sub in and see if left side equal right side. So thank you so much, and I will continue the lesson in the next video. Bye.